like this. What's that going to be equal to? Not 0. I mean, the thing has moved some in the x direction, I would hope. Right? Yeah. In the situation we were talking about previously. So, Leo, what am I going to get here? What's x minus x naught? That's what? That's some displacement, some distance, right? So v naught in the x direction times what? T. Very simple, right? There's no acceleration in the x direction. And so distance is just rate times time, as you may have learned earlier in math or science classes. So it's just velocity times time is a distance under no acceleration, right? Is that true for y? No, it won't be true for y. And we'll see that in a second. But, okay, so v naught x, what is that? We already discussed this. It was your do now, guys. Okay, v naught x is the x component, right? Which we can see from a triangle as v naught cosine theta. So everybody clear on that? Yes? Yeah. I'll take that as a yawn of improvement, Matt Wysocki. Okay. So if that's true, then I rewrite this guy like this. X minus x naught is equal to v naught cosine theta t, or vt cosine theta if you want to write it that way as well. So what does that tell me? What physical quantity does this give me, guys? Yeah, the total displacement in the x direction, if I can find out what t is, right? So that's like where it's going to land, right? Or the distance, the total distance that it will cover in some amount of time, as long as I know the initial velocity. Okay? So if I can find the time of flight of the object, then I'm good to go. Now I'll know exactly how far this thing went, right? But since we have g, we have acceleration in the y direction, right? Or g. So that changes things. And the y direction isn't as simple. So we want to look at y minus y naught and go back to the kinematics that we've just finished deriving. Remember that from last time? Okay, so we've got y minus y naught, and what is that going to be equal to? We might want to start with the y component of the initial velocity. What's the y component of the initial velocity? It's going to be v naught sine theta equals v naught y, the initial y velocity, right? Okay, so how do I combine this thought with a kinematic equation like we were looking at with x in order to get a little further here?
We can use the one with 1/2 at squared.
Right. So that kinematic equation was v naught t plus 1/2 at squared, right? So what would I do to rewrite that explicitly for this? It has to be the y component. So v naught sine theta t. And then what? Anybody have a guess here? Minus 1/2 gt squared. Okay. So what does that give me? Displacement in y over some amount of time, right? This No, this is only applies after that acceleration is gone. So for an object that's thrown, it means after it's been released. There's no other force being applied to it but gravity. Okay, if there's a constant force on it also, you have to know the direction of that force, and this, you would have to go back and redo this knowing what the other accelerations are that are present. So you'd have to take that force, break it into components, apply an acceleration in that direction, figure out what the net force or net accelerations are on the object, and it's not terrible, but it's a little more complicated than this. We will do some things like that at some point or another. It's not that it's negligible, it's that we're choosing to only look at the object after it's been released. You understand? So it's not like it's negligible as in the effect is small. It's avoidable because I can choose the parameters of how I'm approaching the problem. So in this instance, I need to know that it's been released already, and that it's not being acted upon by any other force. What I was trying to say is that this is the same for an object that's thrown straight up. Okay, as it is for an object that's at some other angle, provided I know what V naught and the y direction is, V naught sine theta. Okay, if I know that, then this is the same whether I threw the thing straight up or I threw it at some trajectory. Okay, so if we want to, we can go a little further with that. I don't know if I want to go there yet. Hold on. So maybe we can find a way to combine some information, x and y, to get a more complete picture. Okay? So how did we deal with distance in the x? We had this x minus x naught was equal to what, Van? V naught cosine theta t, right? Okay, solve it for t, and what do you get? X minus x naught over V naught cosine theta, right? Okay, so now I want everybody to take this and plug t in the equation for y that we had. Okay, can we do that? So I'm going to get y minus y naught is equal to what? V naught sine theta times x minus x naught over V naught cosine theta, and then minus 1/2 what? G times x minus x naught over V naught cosine theta quantity squared, right? Okay.